Bismillah, alhamdulillah, salatu wassalamu ala rasulillah. Our class today, inshallah, will be about section 1.5. This section is about complex numbers. We will see together what we mean by complex numbers, what they are, why we need them, and how to do the algebraic or the arithmetic operations, adding, subtracting, multiplying, dividing these numbers. Then we will mention how to deal with square roots of negative numbers, and finally the complex solutions of quadratic equations. Clearly, this is a quadratic equation, x squared plus 1. How to solve such equation? Just we will subtract -1 from both sides. This is, of course, also can be considered as power equation, as we studied in P8. So just add -1 for both sides, then take the square root of both sides. If you take the square root of both sides, you will have a positive or negative, the square root of -1. Now, this square root of -1 is considered as an imaginary number. It is not real number. So they denote it by I. So let's call this I. And of course, if you have that, it means that I squared is -1. So just here, this is the x will be here, positive or negative I. And if you square both sides, you will get this. So I squared is 1. In fact, this is just was the beginning. In fact, this idea has been generalized to be in this form. So this is the imaginary unit, they call it. The imaginary unit I, they just take it from the first letter from imaginary. In general, the definition of the complex numbers is as follows. The complex number is a number that can be written in this form: a plus bi. I, what is I? I is, of course, this number that I is square root of -1 or I squared is -1, where a and b are real numbers. This is called also the standard form of the complex numbers. A is the real part. This part here is the real part. B, not bi. B is the imaginary part, not bi. I is the imaginary unit, so it is there. Two complex numbers are equal to each other if their part, real part, equals to the imaginary part. So when you have two numbers, let's say a plus bi and c plus di. These two numbers are equals to each other if a is equals to c and b equals to d. This is the meaning of that. Okay, let me go back now from where this idea it comes. I, this I, since it is not real, why we need it? So in fact, it is not that it is not like the name is looks like. It is imaginary. Imaginary numbers, they are in fact useful not only in mathematics. So with the help of them, we can solve this equation now. Previously, we said that this equation has no real solution. Now it has complex solution. In fact, it has two complex solutions, I and -I. Not only in mathematics, also in other sciences as well. For example, from the electrical theory. From the electrical theory, the reactance of a circuit is a quantity whose measure is imaginary number. In fact, when they work a shabab, like I don't know exactly, like 300 years ago, when they work with the relationship between the electrical items or the electricity and the magneticity, they realize that always when they try to solve or to model the relationship between them, they get equation like this. Not necessarily the same, but they get equation with no real solution. So they stopped there. They said, oh, there is no relationship between them, so maybe there is something wrong. And they stopped there until they came with a brilliant idea. They said, let's continue. And let's call this I, let's give it a number. Since it is not real, since it is not real, it is imaginary. Imaginary is the opposite of real. So let's call it I and continue the proof. When they continue the proof, they found a very interesting theorems and results like Maxwell equations and many other equations in the circuit theory. For people who will study electrical engineering, they will study more about this. So now, in fact, the electricity, the reactance, الحث الكهربائي في السيركتس في الدوائر الكهربائية, the unit of measuring of these kinds of stuffs, it is imaginary number. It is just imaginary number. You cannot see it, but you can feel it. So if it is not there, if you cannot see it, it doesn't mean that it does not exist. It is there, and it is in fact imaginary number. Okay, these are some complex numbers in the standard form. 3 plus 4i. The imaginary part is 4, and the real part is what? Is 3. Similarly here, the real part is a half, and the imaginary part is -3. By the way, Shabab, when we talk about, I mentioned this maybe with the previous class, not with you. When you have a plus bi, in fact, you will study this later in more advanced courses. In fact, can be represented by a points in the plane. So this point A and B, it can be, of course, described like the point A here. This is the real axis, and this is the imaginary axis, the x-axis and the y-axis. And this is B. So any point, in fact, in the plane can be considered, of course, as a complex number. The coordinates, the real part and the imaginary part of the complex number. For the geometrical description of these numbers, you will study them more in more advanced courses. In this course, we will study just in this class. We will just introduce you to these numbers, just this brief introduction. Now here, 6i is purely imaginary. There is no real part here. So the real part is what? So in fact, it is 0 plus 6i. And -7, it is purely real. There is no imaginary part. In fact, it is plus what? Plus 0i. There is no imaginary part here. In fact, it is a real number with imaginary part equals to what? To 0. So what we can conclude from the last one here, every real number is a complex number. Is that true? Every real number is a complex number. How? How it is true?
True, because I is equal to 0. The term of
I equals 0? No.
No, B equals 0.
You mean the imaginary part equals to 0? Yes. Every real number is a complex number with imaginary part equals to what? To 0. And this is, of course, what we did, ya Shabab, with numbers. Do you remember the story of numbers? We started by natural, then whole numbers, then integers, then rational and irrational, and then real. Now, real number in the system of real numbers, we cannot solve equation like x squared plus 1 equals to 0. It has no real solution. But now, in the complex number system, every polynomial equation of degree n, whatever n is, it has a solution. It has a complex solution. No need to extend this system more, because every polynomial has an equation here. And this is later, we will mention it as the fundamental theorem of algebra. Okay, so you should know, Shabab, that the real number now set is a subset from the real complex numbers. Now the powers of I to the power 1, it is I to the power 2, it is the square root of -1, it is -1. Now what is I to the power 3? It will be I to the power 2 multiplied by I to the power 1. These multiply by each other. -5. What will be I to the power 4? I to the power 4 will be I to the power 2 multiplied by I to the power 2, which is what? -1 multiplied by -1, it will be 1. What is I to the power 5? It will be I to the power 4 multiplied by I. What is I to the power 4? 1. 1 multiplied by I. So it will be I. I to the power 5 will be I. I to the power 6 will be -1. And I to the power 7 similarly will be -I. I to the power 8 will be what? 1. Notice that always, if you continue this way, block and so on, always the result of the powers of I always will be what? I or -I, 1 or negative. This is the only outputs that you have. 1 or positive 1, one or negative 1, I or negative I. Okay, how to know if it is a big number? The idea or the criteria is here. Look, I to the power 4 is what? I to the power 8, I to the power 12. Always when you have multiples of 4, I to the power 4, I to the power 8, I to the power 12, 16, 20, 24, 28, and so on, always it is what? 1. So this will help us a lot to find the powers of I to any power, I to any power. How to do that? Remember this, I to the power 4n, whatever n is an integer in here, by z we mean integer numbers. So if z is, if n is any integer number, I to the power 4n is 1. Like what? Let me give you an example I will mention in the next slide. I to the power 23. What is I to the power 23? Who can tell me? Yes. Give me the result. Yes, Hassan. Give me the result if you have the answer. Negative I, you are right. It is negative I. How do you know that? It is not difficult. I to the power 23, it is what? It is I to the power 20, I to the power 3. I to the power 20 is what? Why it is 1? Because 20 can be divided exactly by what? By 4. So it is 1 multiplied. If you want to do it with more steps, I to the power 20, it is I to the power 4 all to the power 5. And I to the power 4 is 1. 1 to the power 5 is 1. 1 to the power. So it is in fact 1 multiplied by I to the power 3. You should know this, Shabab 4. It is negative I. So it is negative I. You can do it whatever. If it is Shabab I to the power 123, what you will do? The same idea. It will be I to the power 120 multiplied by I to the power 3. 120 can be divided by 4. Divided by 4 exactly. It will be negative I also the same. So you can find I to any power. Just divide by 4 and the remainder will be I to the power the remainder. Yes.
We take any number, but say 42, right? Can we select the 40?
This is what I said, Hassan. This is what I said. Divided by 4. Divided by 4. Write it as I to the power 40 times I to the power 2.
Okay.
Why 40? Why 40 especially 40? Because it can be divided exactly by 4. Why you said 40 plus 2, not 41 plus 1? Because you choose a number that is multiples of what? Of 4. Yes, now how to add, subtract, and multiply complex numbers. The idea is so easy. What you did in B5, do you remember section B5? You will do it here. So how to add? You will just combine like terms, real with real part with real part. A, here when you add two numbers, A plus C plus BI plus DI, and then take I as a common factor. The same as we did for algebraic terms. Similarly for subtraction, be careful, of course, about here. It will be A minus C and B minus D. The description is here if you want to understand. Now, what I want to mention more is this, the multiplication. Look, when you multiply two complex numbers, again, you will apply the FOIL. Do you remember the FOIL that we have studied also in 1.5? You will apply it here. It will be A multiplied by C, then by the I, then BC by this. Do it like this. When you simplify, what you will get? A by C, it will be AC. Now, when you multiply BI by DI, what you will get? Negative BDI. It will be B DI squared. What is I squared? Negative 1. So it will be negative 1 multiplied by BD, and this will be what? Negative BD. And here we are. Now, when you multiply A by DI and then B by CI, here we are. Take I as a common factor. No need to memorize this formula, but if you, it is not bad. I think it is easy to do it using FOIL. Let's take some examples. Here, it is about adding. So what you will do, real part plus real part, imaginary part with imaginary part. So what we will get? It will be 7 plus 3i. This plus this, it is 3 plus 4, 7, 5i minus 2i, 3i. When you subtract, be careful, it will be 3 minus 4, and 5 minus 2, it will be plus, so it will be -1 plus 7i. Now, when we multiply, what we will do, you can do FOIL, no problem. This multiply by this and then by this, like that. Or you can do it quickly by using this formula. How? Multiply the real part by the real part and then add it to the imaginary part by the imaginary part. So it will be what? It will be 3 times 4, 12, and 5 times -1, it will be negative. 2 times 5 is 10. I squared is what? -1, so it will be plus. Plus I, now you multiply 3 by -2, it will be -2, -6 plus 20. It is what? If you want to write it, it is -6. We multiply now this one by this one, the outer terms, and this by this. So what you will get? -6 plus 20 I. All of them, they have I. Here you will have what? 22 plus 14i. That right? Why minus? Who said minus? It is 20 minus 6. It is positive 14. Now, we have mentioned this. What is I to the power 23? We solved it already. You can solve it this way, or the best way is the one that we used before, this one. Now, the conjugate, you know what is the conjugate before. If I give you, do you remember what we did? If you have square root of x minus square root of y, what is the conjugate of this? Square root of x plus square root of y, is that right? So in general, when you have a minus b multiplied by a plus b, these are two conjugate quantities. In fact, the product of them will be difference of squares. Here we will have a squared minus b squared. Here we will have what? X minus y. Now, we have here not the conjugate only, we have here the complex conjugate. So what is the complex conjugate of a number z? If you have z equals to a plus bi, its complex conjugate, which denoted by z bar. Z bar will be a minus bi. What happens? We change the sign of what? Of the imaginary part. So this is why it is called complex conjugate. Let me give you an example. What is the conjugate of 3 plus 2i? 3 minus 2i, you are right. What is the conjugate of 1 minus I? 1 plus I. What is the conjugate of 4i? Negative 4i. Just change the sign of the imaginary part. What is the conjugate of 5? Negative 5. Why it is negative 5? 5, it is 5 plus 0i. So its conjugate is what? If this is z, what will be z bar? 5 minus 0i. The complex conjugate. This is, ya shabab, what we said here. Look, a plus bi, its conjugate is a minus bi. Be careful, please. So let me ask you this. What is the conjugate of I plus 1? If this is z, what is z bar? Is it I minus 1? No. Minus I plus 1. So be careful. You should write it in the standard form. First of all, you should write this as 1 plus I. Then its conjugate will be 1 minus I. Be careful. This is why we said complex conjugate. In the complex conjugate, we change the sign of the imaginary part, not the real part. Great. Now, what will happen if we multiply a complex number by its conjugate? Look, what will happen if we multiply a plus bi by a minus bi? Difference of squares. Is that right? So it will be a squared minus b squared I squared. What is I squared? Negative 1. So it will be I squared plus b squared, because I squared is negative 1. Negative 1 multiplied by negative will be positive. So here we are. What do you notice? What do you notice about that? We multiply the complex number by its conjugate. The product, the result of the product is what? Real number. This is a real number. A squared plus b squared is a real number. It is just the square of the real part plus the square of the imaginary part. Now, the last operation that we need to deal with is the dividing. How to divide a complex number by a complex number. If someone asks you how to divide a complex number by a complex number, what will be your answer? Your answer should be like this. Write the numerator in the standard form, a plus bi, and write the denominator also in the standard form, a plus bi. Let's say c plus di, another number. Then to divide, what you need to do, multiply the numerator and the denominator, both of them, by the complex conjugate of the denominator. So here we multiply by what? By c minus di and divide by c minus di at the same time. What is this? This is the conjugate of the denominator. Do you remember rationalizing? Idea similar to that. Now, what you will have in the denominator? C squared plus d squared. No more I. Don't write any I in the denominator, Yeshua. Always, when you have, it is like rationalizing. When you have a radical in the denominator, try to remove it by rationalizing. Here, similarly, when you have I, imaginary part, in the denominator, try to write it in the standard form. And this is, of course, after that, you will multiply this by using the FOIL, the usual multiplication. Let's take an example. We will apply now this formula. Now, how to divide? What is this? How to simplify this? It is, in fact, dividing. We are dividing two complex numbers. So what we will do? We will multiply by 1. We will multiply by 1, but not any one. By a hero one. What is it? 1 plus 2i by the conjugate of 1 minus 2i, which is 1 plus 2i. So we will divide and multiply by 1 plus 2i. This is 1. We want to maintain the equality, to have the same value of the number. So this is why we multiply by 1. 1 plus 2i over 1 plus 2i. What is in the denominator should be easy, Shabab. Who can tell me? This is equals to what? 1 plus 4, which is 5. For the numerator, multiply by this, it is easy. You can multiply 3 by 1, then this by this, then this by this. It is easy. So this is what you have. Now, is it now in the final form, in the standard form? Is it in this form? This is the standard form. No. Is it a number, a real number plus a real number multiplied by I? No. So what should we do? We should separate. It will be -7 over what? Over 5 plus 11 over 5i. Now this is in the standard form. This is A, this is what? B. And this will be A plus BI. Clear? Always, ya shabab, when you have complex numbers, write it in the standard form. Let me, before solving this question, let me ask you this. What is 1 over I? Who can tell me? What is, again? What you are saying, Mahmoud? I what? No, what is that? I cannot understand you. What you are saying? This is how to say it. After 1 month or 7 weeks, you cannot say that. You cannot say I to the power -1. It is I to the power -1. So what is I? The question is again, what is I to the power -1? It is 1 over I. What is this? Is it in the standard form? Is it written in the standard form in this way? Is it in the standard form? 1 over I, 1 over I, or I to the power -1. Is it in the standard form? No. How to write it in the standard form? We are dividing, ya shabab, here a complex number by a complex number. 1 is a complex number, even it looks real, but every real number is a complex number. So it is the idea the same. What we will do to write it in the standard form? We will multiply by what? By -I over -I, the complex conjugate. If you multiply by I over I, it works also in this case only. So what you will get, 1 multiplied by -I, it is -I. -I by I, -I squared. What is I squared? So this is -I squared. So it is -I by -1. So it is -I over 1. So it is negative what? So what is the answer now? What is 1 over I? It is -I. Believe it or not. This is the answer that I was expecting from you to say. So now we will use the same idea here. Look, how to divide this number by this number. What we will do? We will multiply by what? By one, but what? Not any one, by negative 4i over negative 4, and that's it. And it works the same. What we will have in the denominator? What we will have in the denominator? 16. Come on, guys. And of course, in the numerator, you can multiply. It will be 7 by negative 4, it is 12. I, and it will be here. When you multiply negative 4i by 7, here it is. And negative 4i by I is I squared, so it will be 12. Now simplify. It is not in the standard form. 12 over 16 minus 28 over 16. This is how to be written in the standard form. The last part, or no, not the last part. In fact, it is the one before the last part. The square roots of negative numbers. And this is similar to what we said in section B2 and section B4, I think. Yes. Do you remember what I told you? What is the square root of 9? 3, not positive or negative 3. Similarly, what is the square root of negative 9? This is negative. Why? If it is a 3, what we are doing? Why we study complex numbers? This is I square root of 9, which is I squared, which is I multiplied by 3. It is 3i. This is 3i. Okay. So similarly, it is not positive or negative 3i. This is what we call, Shabab, here we call it the positive square root or the principal root. Similarly, the principal square root of negative r. If negative r is negative, look what they are saying is this statement has a meaning. Is negative r is negative. Who can rephrase this? If r is positive, you mean. If r is positive, this will be negative. Okay. Now, whatever, the idea here is what? When you have r positive, which means negative r is negative, then the square root of negative r, it is I square root of r. If r is negative, what will happen? If r is negative, negative by negative, positive, and this will not be complex. It will not be imaginary. It will be real. Now, if you want to talk about the positive and the negative root, they are two. In fact, let's take some examples about this. And this is very important, ya Shabab, remark about how to write. Write it, ya Shabab, when you have square root of bi, like square root of 3i, don't write it like this. Maybe you will get confused. You will think about it this way. So to avoid this confusion, write it as I square root of 3. It is just a matter of make it more clear like this. What is square root of negative 1? It is I square root of 1, which is I multiplied by 1, which is I. I square root of negative 16. It is I square root of 16, which is 4i. Square root of negative 3. I square root of 3. That always keep it in mind like that. And square root of 3 is square root of 3. Now, when this is a very important remark, when working with negative radicands, use the definition. This is the definition. This one. Before using any of the other rules of radicals. Let me give you an example about that. Is this always true? The square root of a multiplied by the square root of b equals the square root of ab? Always true? It is not always true. We will see that together. We have studied this in P2 and in P4. But we said something there. If a and b are what? Are non-negative. Let's say positive or 0, okay? So this is true only if a is positive and b is what? Because this will be, of course, defined in the complex, in the real number system. Now, when we are in the complex number system, we have no problem, but it is still also not true. We will see that. So when this is not true, this is not true when both are what? When both are negative. If one of them, by the way, is negative, it works. We will see that together. Now, let's see why it doesn't work if both are negative. For example, what is the square root of -2 multiplied by square root of -3? It will be what, according to the definition? What should we do here? It will be I square root of 2 multiplied by I square root of, what is I times I? I squared, which is negative. Square root 2 of 2 multiplied by square root of 3, square root of 6. So we will have I squared square root of 6, which is negative square root of 6, right? Now, what will happen if we apply this here? Look what will happen. If you make this equals to this, it will be square root of both, -2 times -3. You will have square root of what? Negative by negative is positive, 2 times 3 is 6. Is this the same as this? They are not. So be careful when you multiply square root of a negative number by square root of a negative number. You should use the definition because here you have complex numbers. So keep this in mind. Now, when multiplying, how to avoid this error, ya shabab? When multiplying radicals of negative numbers, express them first like this. I square root of, where R is, here R is positive. Then, of course, continue. Let's take an example. What is square root of -7 by square root of -7? It will be I square root of 7 multiplied by I square root of 7, which will be I squared. It will be -7 at the end. Okay. If you didn't, if you distribute, write them under one radical, it will be 7, not -7. Okay. By the way, if we are dividing it, no problem, shabab. Look here. When we divide square root of a negative number by square root of a negative number, what you should always do is write it in the using the definition. It will be I square root of 20 over I square root of 2. I square root, I over I is what? So this is why here it doesn't matter, because they will be what? Cancelled. But when we multiply, I with I will not be cancelled. It will be -1, not 1. So why you have to be careful when you multiply. But when you divide, they will be cancelled anyway. And this, by the way, this result will be the same as you will say, as it is the square root of -20 over -2. But to make sure about any negative by negative, it will be positive, and this will be square root of 10, which is the same answer. If one of them, by the way, also, shabab, if one of them is, we say that if you have here, if you have one of them is, both of them are negative, you have to write them first as I square root of B, I square root of A, like the example that we have here. Now, if one of them is negative, no problem. Check that. If we have time, we can do that at the end. Now, how to evaluate some expressions and write them in the standard form? Always you will write them in the standard form. How to do that? To do this, you should write first this one as what? I square root of what? 3. And this is 3 plus I square root of 4. Now, I square root of 4 is what? 2. This is easy. What is square root of 12? Simplify it. 2 square root of 3 minus I square root of 3 multiplied. Now it is about multiplying. It is usual multiplication. Use FOIL, and this is what you have at the end. Always simplify. Write it in the standard form. The last part, ya shabab, of this section is the one that we have mentioned in 1.4. Do you remember the quadratic formula? This is the quadratic equation. This is the quadratic formula. We say that when the discriminant, this quantity inside the radical, when it is negative, this has no real. But of course, in the complex number system, this equation will always have what? Always. Do you look at always have solutions? Always this kind of equation will always have solution. Like this equation, for example, x squared equals to -4. It has two solutions, -I and I, 2i and -2i. Let's look at the solution of this equation, which is just mentioned above. It is just positive or -3i. And notice that always the solutions are what? Conjugate of each other, complex conjugate. If 3i is a solution, -3i is a solution. For this one, you cannot factor. So what you will do, you will use the quadratic formula. Now, if you simplify, you will get square root of -4. The discriminant is negative. So it will be 2i. Simplify, it will be -4/2, -2. 2/2 is 1. So here we are. What are the solutions? 2 plus -2 plus I and -2 minus. What do you notice about them? Both are what? Conjugate of each other. And this is always, it is mentioned here, always. When you have a quadratic equation, then if a plus I is a solution, then its conjugate also is a solution. This is another example. By using the quadratic formula and simplifying, the solutions are conjugate of each other. This is the summary of this section. All what you need to remember, mainly, Shabab, you need to remember the standard form, how it always looks like, the powers of I, the conjugate, the complex conjugate, how to add, subtract, multiply, divide complex numbers, and how to deal with the square root of negative numbers. Be careful when you deal with them. There are many solved exercises for you to practice. Please practice by solving and then check your solution. Don't read solutions only. Let's solve a recitation exercise. Let's solve this. I think this is the best exercise to summarize all what we did today. If you can solve this exercise, then this means that you mastered the topic of the class of today. Please, in your notes, try to solve this exercise. You have a complex number. He wants you to write it in the standard form. Then find the real part and the imaginary part and subtract them. The imaginary part minus the real part. Interesting exercise. You will learn a lot from this. Let's take the attendance. Let's check the answer. The answer is 0, which means that x equals to y. This is the meaning of if the answer is 0. So y is the same as x. So the imaginary part, the real part, is the same as the imaginary part. So you should have something plus something. So the question is what? This number, write it in the standard form. Write it in the standard form. Write it as at the end as a real number plus a real number multiplied by. Then find y minus x. So what we will do to solve that, Shabab? Let's start. So this is equals to what? What is the square, the cubic root of -125?
-5. Just -5.
Sorry?
No,
No, what is a? You say a.
Yeah, I.
You mean. So what is it? I square root of? From where you are bringing this? This is cubic root. And this is square root. What is that? Ya Shabab, Ya Shabab, Ya Shabab. Be careful. This is a nice one, by the way. What is the cubic root of 8? What is the cubic root of -8? -2. We are not talking about odd radicals here, Shabab. It is just about square roots of negative numbers. What is square root of -8? This is I square root of 8. Okay. Now, when we have square roots, be careful. So this is what, ya Shabab, the cubic root of -125. It is just -5. What is the cubic root of 125? It is 5. And this is, of course, when it is negative, it is negative. So don't worry when you have odd radicals. Now we have I next to it. This is I minus, what is the square root of -25? It is I square root of 25. I want you to always use this to avoid any errors. And this will be I square root of what? Of 1. Is that right? Now, let me do that in the next step. Now, what is 2i minus 1 multiplied by 2i plus 1? They are complex conjugate. Are they complex conjugate? No, they are not complex conjugate. They are conjugate, but not complex conjugate. So you have difference of what? Difference of squares. So it will be what? 4 I squared minus 1 squared. This is what you will have. And here you have negative I to the power 130. So it will be what? What is negative I to the power 103? When you have something like this, what you should do? You should write it as negative 1 to the power 103 multiplied by I to the power 103. What I did, when you have A times B all to the power n, what is this? This is A to the power n, B to the power n. Okay? So this one can be written as negative 1 to the power 103, and this is I to the power 103. Let's do it this way. Of course, you can do it by other methods, but let's do it this way. This is equals to what? Negative 5I. Now here, Shabab, we have I by I. It will be what? I squared multiplied by negative. It will be positive. It will be plus. Square root of 25 is 5. Square root of 1 is 1. It will be what? 5I. Is that right? Is that right? I squared is gone. So it is there. It is 5 only. How the numerator is 0 now? How the numerator is 0? It is not 0. This is your mistake. You put it like this, so it is 0 now. So this, it is not 0. This is in fact 5 plus 5 minus 1. Now here we have I squared. What is I squared? It's negative 1. It will be negative 5. Is that right? Negative 4, negative 1, negative 5. What is negative 1 to the power 103? Always, guys, when you have negative 1 to the power n, it will be either 1 or positive 1 or negative 1. Is that right? Why it is not writing? Okay, it will be 1 or negative 1. It is 1 if n is what? If n is even. And it will be negative 1 if n is what? Odd. So this is odd, so it will be negative 1. And what is I to the power 103? It is I to the power 100 multiplied by R to the power 3. Now, Ya Hassan, it is the same idea. Your idea that you mentioned. Why 100, not other numbers? Because, of course, I will think about a number that can be divided by what? If you divide this by 4, you will get at the end 3. The remainder will be 3. So you think about the multiples of 100. Now, what we will do, Ya Shabab, in the numerator, it will be 5 minus 5i. Is that right? Write it in the standard form. Now here we will have negative 1 by negative 5, it will be 5. And I to the power 100 is 1. And I to the power 3 is what? Negative I. So this will be 5 minus 5i over negative 5i. Is that right? How to simplify this, Ya Shabab? Take 5 as a common factor in the numerator and cancel it with the 5 in the denominator. You will have 1 minus 5 over negative I. Do you see what I did? I just factor out 5 in the denominator, cancel it with the 5 in the denominator. Just to simplify the calculations, you can do it without this step. Now what I will do here, I will multiply by what? By the conjugate, the complex conjugate of negative I, which is I. Then this will be what? In the denominator, what we will have? Negative I by I. It will be negative I squared. I squared is negative 1. It will be 1. We will have 1. And 1 minus I, it will be I minus I squared, which will be plus 1. Is that right? Write it in the standard form. It will be 1 plus I over 1 and 1 over 1. Now compare it with what? With what is he gave you on the right hand side. He said that this equals to what? This is equals to what? X plus I, Y. So this means that what? This means that X is what? And Y is what? So what will be the question now? The question is about what is Y minus X, which will be 1 minus 1, which is what? 0. We have learned a lot from this exercise, Shabab. So please try to resolve it again and solve similar questions in the old exam questions similar to this question. Thank you and see you tomorrow, inshallah. Any questions?